Okay, John Ramon's House of Math, working with Jack, and we have some spectators.
Hi, I'm here to watch.
This will be a recording. I'll probably put it on the super duper super secret math group. All right, excellent. Yeah. Now turn it around and build me nines.
Wait, take out the nines and do nines?
Yep. Yep. Or you can, however you want, whatever's most comfortable for you. See, normally you'd be racing me. Excellent, excellent.
We never do races.
I know. You got to race your brothers and sisters, or your brother and sister. See, what it can be is you're building your 10 on that side, and she's building her 10 on this side, right? You face each other like you are now. I think there's some more combinations. Are there more combinations? Keep going.
Okay.
And I think you'll notice you're going to make your nines times tables there.
Oh, hold on.
Hold on. Yeah, I know you got one. We got one to go in there.
7
Excellent.
and 8, and then
there you go. Is your mom home?
yeah.
Ask her to come when she's available. She doesn't have to, you know what I mean? She, at her leisure. We've had some games with these boys, her and her, the mom and the two siblings playing What's Another Cup. And last time it was like, oh, one more. They didn't want to quit. See, that's the thing. And by the way, both of you boys could be doing this and make $60 an hour or more. I have students that do $120 an hour. They charge $60 for a half hour.
Mm-hmm.
But they're in California. They're in Walnut Creek, which is, you know, wealthy.
She can't. She's making dinner, and she might come for the last 15 minutes.
Yeah, that's what I mean. I told her at her leisure. She's making food for you. Cool. What are you having for dinner?
No idea.
No idea. Whatever she makes, I'm sure it's gonna be delicious. All right. Close your eyes and tell me all the combinations for 10. Just close your eyes and tell me all the combinations.
1 plus 9, 8 plus 2. Should I just do that?
Keep going.
9 plus 1, 8 plus 2, 7 plus 3, 6 plus 4, 5 plus 5, 4 plus 6, 3 plus 7, 2 plus 8, and 1 plus 9.
All right, excellent. So now, what if I had 17 and 7? You got 17 apples, and then my boys give you 7 more apples. How many apples do you have?
So 17 plus 7.
Oh, 17 plus 7.
24.
Very good. Why you ask it like a question when you know the answer?
Mm-hmm.
Okay. How about what's 18? Oh, what's 17 and 5?
17 and 5, 12. No, not what? Wait, yeah.
17 plus 5.
22.
Right. Because the 7 takes the 3 and you got 2 left, right?
Mm-hmm.
Okay, in your mind. All right, what's 30? Oh, let's do 28 and 7. That should be easy.
28 and 7, that would be 35.
There you go. And both of those numbers are on the 7 times table, right? Let's go backwards. What if I said 25 and 7?
25 and 7, 42.
Try again. 25 plus 7.
Oh, 25.
Plus 7. How are you getting an extra 10? There, you got too many 10s.
Oh, 7. Sorry. What was the question again?
25 plus 7.
25 plus 7, 32.
Very good. It's funny. All children throughout all time, including my own sons, do the same thing when they're thinking. What was the question? All right, could you repeat the answer? Anyway, how about now? Let's do some multiplication quick. And see, the last class that I had, Jack, you can't get it wrong. This is homeschooling, right? I'm just finding out what we need to work on or what you need to practice. So if you get it wrong, don't feel bad. It's just like, okay, if you don't know, you don't know, which means that you're going to have to practice more. All right. What's 7 times 8?
7 times 8, 72.
7 times 8. 9 times 8 would be 72. Oh, he's got to go look. See, we know you got to work on sevens.
56.
56 is a good answer. What's 7 times 7?
7 times 7. 49.
And I'll remind my 2 sons, I get paid for this. Okay, let's see here. How about, what's the square root of 64?
Square root of 64. I forgot what square root means.
Ooh, that's important. If you can't answer the question, if you don't know what square root means, that means that I have to take a number, turn it into the square, or turn it into a square and count one side. It comes with this symbol. Hold on a second. I'm all plugged in and stuff because I'm in the. All right, let's get in front of the board here. This is the symbol for a square root. What does that mean right there? It means I'm going to make a square, and then I only want to know one side. And if I have a square, one side is the same every time, right? Ooh, he figured out that it's got to be those.
8.
So it is correct. Square root of 64 is 8. What's the square root of 100?
Square of 110.
All right. Now, I want you to sit up. Is it cold over there?
Yeah.
Yeah, it's cold. Look at me. And look at my boys. Ooh, they're sitting there with no shirts on in the sun because it's nice and warm because they're in Hawaii. And I'm over here in Arizona and I'm freezing to death.
Lucky.
I know. They are. All right. So, go put a shirt on or a jacket or something so you can sit up nicely. That's not going to work for teaching math.
I mean,
Do you already have a hoodie on? Go get a hoodie. Seriously, go get a hoodie. Not your blanket. Go get a hoodie. You got to be able to sit up.
not really cold, but okay.
Okay. And also you're in shorts. Okay. So I want you to, in your mind, close your eyes. 11 times 11. Close your eyes and picture it in your mind.
11 times 11. 111?
Oh my goodness. Here's my big red square. Then what did I say? It was 11 times 11. Can you visualize this?
122.
Ooh, close. How many's going to be in the corner?
What?
How many's going to be in the corner? Look over here, Jack. You don't need to visualize anymore. Can you see it?
Yep.
All right, great. Build it right in front of you. Fast.
Okay.
Get 100. 2 tens.
What?
2 tens. And a 1. Are we not 11 times 11? Okay, now, without adding any more, use your imagination. What's 12 times 12?
121.
121 is the right answer. 100, 2 tens, and 1. What's 12 times 12? Don't build it. Just try to build it in your mind first, and then build it with the blocks if you need to. 12 times 12.
140.
Excellent. What's going to be in the corner?
2.
Try again.
141.
Try again.
144.
There you go. Oh, it's got to be 4 because it's 2 by 2 right here, right?
Yep.
All right. What's 13 times 13?
13 times 13. 160.
Oh, my boys decided to put shirts on. I like it. You don't need them. Why do you need shirts? You're in Hawaii. Anyway, what's 13 times 13?
160.
Excellent.
Something.
So I know what's in the corner. Picture the corner.
165.
Try again. How are you getting 5?
4.
Look in the corner. Look
I
right
know.
in the corner. What? Look in the corner. You're killing me. You're killing me, Smalls.
I am.
Yes, because this is
12.
too easy. This is too
12.
easy.
12's in the
Look. 3 right there and 3 right there. What's the only thing that can fit right there in the corner?
12,
Because 3 times 3 is 12.
I guess.
Is 3 times 3 12?
No, it's
What's
9.
3 times 3?
9.
There you go. Quit trying to make this hard, boy. 3, 3, 3, 3. That's 9. All right, now we're going to get super crazy. What's 14 times 14? Build it in front of you then. Build it. This one I'll give you some slack. You might want to build it.
You show me how to build after I have build.
What? Just put 4 there and 4 there.
Fine. Like this. And then.
Yeah, you need 14 by 14. 10 and 4 and 10 and 4 both ways. And then what's going to go in the corner? I like it. Now add it all up in your head. Look how much math we're doing with just this one problem.
100.
And then
196.
very good job. Winner. All right, so then I say 196. I want the square root. What's that?
Square root of 196.
Did you not just build a square?
Oh. But which 4?
How is it 4? 16 is the square root. 4 is the square root of 16. But I got 196 here. So how could that possibly be 4?
16?
What's this one side right here? 16.
Oh.
What does this symbol mean, son?
14 on one side.
There you go. Do you feel silly now?
I guess.
Okay. Dude, and I get paid. I laugh for an hour and I get paid. Okay. Now let's do some algebra. What do you say? And see, I save what's under the cup till the end of the class because that's like the reward. And if I don't do what's under the, and then they don't want to quit. All right. So here's what I'm going to do. I'm going to give you the code. You're going to build the rectangle and then you're going to tell me the sides. Are you ready?
Yep.
All right. You want a hard one or easy one to start?
Easy.
Okay, fine. See how you are. How about x squared plus 7x plus 12? And see, you two can do it in your heads, right? I assume you can just nod if you can do this. What are the factors, right? No problem. All right, what do you got? What do you got? X squared, 7x, and 12. Tell me the sides.
X plus 4 and X plus 3.
Very good job. Correct answer. X plus 4 and X plus 3. And it doesn't matter what comes first, right? It just matters that the way you built it, it's X plus 4 this way and it's X plus 3 that way. And yes, it does matter. And wait, I'll draw a fast one, all in one color. There's my X squared. 1, 2, 3, 4. 1, 2, 3. And then I'm lazy. I'll just put 12 there. Okay. Good job. And now here's the other thing, Jack. If Jack, look over here. Get out from underneath your covers. It's not that cold. And like I said, if it is, go get hoodie like me.
It's been cold the entire morning at school.
Yeah, I'm sure. This is my least favorite time of the year, except in Hawaii. Whenever I was on the mainland, like when I used to work for Mortensen Company, right about now was when I was getting a plane ticket home. For sure. If I didn't get home by Thanksgiving, I for sure got home by the first week of December.
I had to go home. I had to go out for recess.
Mm-hmm. You had to go out for recess, and it was cold out there.
T-shirts.
See, I have you boys either, right? We have no clue what it's like to have to go out for recess, and you don't want to go out because it's cold out there. Right?
Yeah.
That has never happened in your lives.
Yesterday, we spent 5 hours at the beach and did dawn patrol because Jaws was breaking at 30 feet. So we went to 4 different beaches in Twin Falls.
He's just rubbing it in. He's just rubbing it in.
We're letting you know. Hawaii's pretty cool.
No. We went to 4 different beaches. Decided we only liked one of them.
Yeah.
So you stayed at one beach. Yeah, there you go. That's how it is. All right, Jack. That was too easy, so I'm gonna make it harder. He's all crawling under the bed.
You gotta come look.
Squared. I don't know. Let's make it. Oh, I gave this to the student. She was 16 and she got it. Let's see if you get it. X squared, 11x, and 30. Jack, get out from underneath the bed and build this.
Yeah.
Yeah, build it. What? X squared, 11x, and 30.
Oh, okay.
And this is the amazing thing. I still teach them math. You need 11x. So you're going to need some other x out. Yep, you're going to need some x out of there. And previous to this, the issue with this child was he would sugar it up before he came to class, so then he'd be drunk on sugar. It was awesome. 11x and 30. How are you going to get 30 to fit? Get those threes out of there, first off. How are you going to get 30 to fit in the corner?
They're not threes. I
like it. Again, look at how much math he's doing. He has to do math in order to get to the answer. I want 30. Move some more. You're not there. And you don't get to say, I don't know, when you have blocks right in front of you.
don't know.
Yeah.
7.
Ooh, now how many? Now how many? You should be able to count fives.
I'm gonna use 5.
You sure you have 11x?
Nope. Yep.
All right. What's the factors?
X plus 5, X plus 6.
There you go. Isn't 6 times 5 30?
Yep.
And isn't 6 plus 5 11?
Yep.
All right. So what you're looking at is the corner, right? And how did you build it? You built it like this. You built it where there was 5 over here and 6 over here. 1, 2, 3. Oops. Too many. Right? So this has to be 30. Jack, look over here, you monkey. All right. See this? If this is 30, let's use some different symbology, because I just had a woman that was, anyway, teaching it the incorrect way. If this whole thing is 30, and I tell you that one side is 6, what does the other side have to be?
30 and then 6.
What's the other side have to be?
6.
Really? Because 6 times 6 is 30?
6 times 6 equals 36.
Well, then what's the other side have to be? You're
5.
talking about the other. I'm talking about the side that isn't 6. What's the other side?
5.
Has to be. Can it be anything other than 5?
Yeah.
What else could it be?
5.
Anything else?
Nope.
That's why we love mathematics, Jack. Because if you put 5 there, doesn't matter if the teacher hates you. Doesn't matter if you're the kid in the back of the class throwing spitwads. If you put 5, she's got to mark it right. Oh, I shouldn't have said that. Don't get any ideas. I got sent down to the headmaster's office on more than one occasion for spitwad violations. One time I actually hit the teacher in the eye. It was awesome.
What does spitwad mean?
You take a little ball of paper. Am I going to explain this to them? I'll probably get in trouble.
Yeah, explain it to me.
I'm totally not telling. These are stories my boys haven't heard. See, that's why I had a liberal white woman for a mother. She didn't spank me, right?
Oh wait, so you like get like a little ball of paper and like spit on it, then like put it in like draw and like
Something like that, yeah.
I'm telling my
That's
mom.
kid culture. I don't even have to explain it to him. He already knows what it is. They just don't call it the same. All right. Build me a bigger one. How about could you do one with 2x squareds in it?
Yep.
You think so?
All right.
All right. He's ready. Look at him. He's ready. Okay. Can't put anything past this guy. How about 2x squared plus we'll make it where you have to think a little bit. 8x. Wait. Yeah, 3. And that'll be 12, wouldn't it? Wait a second here. If I did 8x? Okay, wait, 8x. Oh, we'll make it 6. There you go. Build me that. 2x squareds. You got way too many x squareds. I like your huge x squared. So let's do that. What would that be? That would be like 900, wouldn't it?
Yep.
So what's the square root of 900?
No idea.
Yes, you do. You got it right in front of you. Count one side.
300.
One side. Is one side 300 long?
Yep.
Is this 100 right here? Or is it 100 all there?
Oh. I don't know.
Yes, you do. Count it. And I don't know is not a good answer. And it makes you sound foolish.
Does?
How far is it from here to here?
Oh, 10. Sorry.
Well, then how many of them do you have in front of you?
She went from here, like all the way down.
So what's the square root of 900?
Square root 900. 300? 10?
10 times 10 is 100. How many 10s do you have along that one side?
300? I mean,
You have
100.
just the side, just the edge. The edge is not 300 long.
Oh. Yes, it is.
No, it isn't.
This is 300.
The whole thing is 300. What's the edge?
Oh, the whole thing. 1? I don't know.
Yes, you do.
No.
What is this right here? How far is it from here to here?
300.
From here to here, how far is it?
Oh, 10.
How far is it this way?
10. 30.
There you go. Is that hard to count?
Yeah.
No, that's hard to count. Is that 300 right there? Is that 30? Is that 10, 20, 30? You're just counting this edge. So what's the square root of 900? Oops, I put 300. What's the square root of 900? Which is right in front of you. So you're telling me that you can't count that one side. He's going hiding under the bed. What is it? What's the answer, Jack?
No.
Sit up, get over here, and count.
All right. So, one side,
Yes.
30.
There you go. Done. That's the only time I get annoyed is when you say stupid stuff like, I don't know, when it's right in front of you. Now, this is not 100 right there. The whole thing is 100, but this side is 10. That side is 10. So it shouldn't have been hard to count 10, 20, 30. You had to count 3 of them. Did you get off? You didn't even get off this hand. Okay, build me this. You can't build it from under the bed. Yeah, build me this.
Okay.
And in the future, I think we're going to have adult supervision for you. Because I guarantee you, if your dad or mom was in the room, you wouldn't act like this. Anyway, build that. 2x squared, 8x, and 6. Build it. Get out 2x squared. It's like having Calvin and Hobbes, except it's Calvin, no Hobbes. Okay. 2x squared, 8x, and 6. Get it out and build it. Get out 2x squareds. Give me 8x and 6 and turn it into a rectangle.
2x plus
2x squareds. That's what you got in your hand. Then you need 8x, which means you need 8 of these. Your little brother can do this.
You can?
Yes, absolutely.
3, 4, And what?
You tell me. It's right there in front of you.
Oh.
I like it. He immediately sees probably 1-6 isn't going to be good, but 2-3s will probably work. Yeah, that didn't work. Keep trying.
That did work.
Do you have 8x?
Oh.
Wait a minute. Do you have 8x? It looks like you have 8. I can't tell.
2, 4, 6. 2, 0, 2.
Okay, then you got
Oh,
6.
8x.
Yes.
1, 2, 3, 4, 5, 6, 7, 8. Yeah, I got it.
All right. So what are my factors? Count it.
26.
Well, what do we call those? We're in algebra now, not in, right? We're not doing, this isn't, let's get rid of this. This isn't 286. This is 2x squared, x, 8x, and 6. So what are my factors? Well, you've got 2x plus how many? Going across.
6.
Yeah. And then what is it the other way?
7.
Look the other way, the other side of the factor. What is it? You've got 2x plus 6 going this way. What is it going that way?
Oh. 8 times 6.
Where do you see 8 times? Show me 8 times 6 anywhere in front of you.
All right. I mean, it's on your screen, so on your
In the blocks in front of you, where do you see 8 times 6? Because you don't. So how far up is it? I'm asking you.
Times 6.
There you go. That's good. You played around with your blocks. Show it to me here. Where is 8 times 6 here? What you see is 8x, and that's a 6. But what that says is 2x squared plus 8x plus 6.
I see 8 times 6.
Now I can see, can you see, and here's for the boys, I don't know if they're watching, but can you see where there could be some problems here? Because this does look like 8x times 6.
Because on
Right? Or 8 times 6. It's not. What we're doing here is 2x squared, 8x. You're counting these guys.
Who's laughing?
Yes, I guarantee it. Anyway,
Nobody was laughing.
so what's the other factor? You still haven't told me how far up it is. So I know how far it is this way. How far is it that way?
Yep.
How far is it that way?
Yep.
Yep is not an answer. How far is it that way?
Up.
Yes. How far is it?
6.
Where do you see 6?
Right here. 2.
Along that one side. All right, let's draw it.
Oh, 11.
Stop it. It's x plus 1. It would be 11 if we're in base 10, but we're not in base 10.
I thought these were base 10 blocks.
They are base 10 blocks, and they're on the x side. So now you're in base x. So 2x squared, 8x and 6. This would be 2x plus 1. This would be x plus 1. And you're right. If x was 10, it would be 11. But we don't know what x is. What if x was 5? What if x was 3? What if x was 0? That's why this is great, JAQ, is because it doesn't matter. We could still do it.
Is base X like a military force?
Base x is like algebra. It's like math.
I'm doing that.
It's a base. Do you understand the difference between bases? Base 10, base 1, base 2, base 5, base 7, base 16, hexadecimal, etc.
Excellent guess.
Yeah, you have no idea, right? And this is the thing, Jack. Most Americans love being ignorant.
Hold
They
on,
love it.
I can
They
pronounce
love that they're stupid. They love that they don't know anything about mathematics.
Vexa, Lega, Sega, Mega.
So X could be 10, X could be 5, X could be 7. But let's say X is 10. Well, then if X is 10, that tells me that across it is 26. What is it down? Or what is it? I'm going to change this thing. I'm going to put it like this. Uh-oh, I don't have enough of these. 1, 2, 3, 4. I'm missing one. There you go. Now there's 6. So you can see that if it's 26 across and the whole thing is 286, then this side has to be 11. And see what I do. And wait, I can even do more math. Can you see? Yes, you can. Let's do it this way. We'll do all of it. This is 26. The whole thing is 286. This side is 11. That means that, well, let's start here. 260. See it? 260. What's left? 26. And then I do one more, and I take away 26, and there's nothing left to count. That's if you know X is 10. We don't know X is 10. How many times have I told you? He's always trying to trick you into thinking he's a 10. Could be 3, could be 5, could be 7. What if X is 0? Well, if X is 0, then all of this is gone, and you just have the corner where I have 6, and the whole thing is 6, and of course that's 1. Now, that's if X was 0. In other words, none of this is there. So we got rid of everything, right? And all we're looking at is that part right there. Now, Jack, what if X was 2?
Then I get more chocolate candy.
What if X was 2?
Well,
then I'd have, what's 2 times 2? 4. Right? Plus 6 is 10. And then what I have over here, 2 plus 1 is 3. And that would mean the whole thing is 30. And we could do all the math if you wanted to, but you don't. 2 times 2 is 4. So this would be a 4 and a 4. Right? Because that would be a 2 square and a 2 square. These would be all 2s. And then that would be your 6. And the whole thing, sure enough, would be 5 times. Wait a minute. It wouldn't be 5. It would be, because each one is 2, it'd be 3, there you go, times 10, which is 30. Right? Because use your imagination. This is an X square when X is 10, but it could just as easily be this size, 2 by 2, which is what we just did. And then you'd have a 2 square, and a bunch of 2s, and you'd wind up with a square that was, that's if X was 2. What if X was 5? What if X was square root of 2? What if X was a third? We can still do it. That's why the algebra, it's almost like magic, but it's not. It's just math. All right, try and build another one and give me the factors. Oh, wait. One more thing. If the whole thing, how are we doing on time? What time is it?
last minute, I looked like 2 minutes ago and it was 5:06.
Okay. And what time did we start? We started like 4:30, right?
Mm-hmm.
Okay. So we got more time.
We got
Ooh, do some math. How much time do we have?
12 more minutes
12 more minutes.
from last time I looked.
Okay. So what if this is X plus 1? What does this side have to be?
X plus 1, X plus 2.
Look in front of you, dork. You built it even.
I'm a dork.
Yes, you absolutely are. Sit up and take a look at this. If I was there, your butt would be hurting.
It would?
Yeah, absolutely. Anyway, move that red square.
Are you like mad at me or something?
No, you just need discipline. You lack it.
What does discipline mean?
Yeah, see, there you go. Move that one red square.
All right.
and tell me what the other side is.
Of this?
You already know. I told you one side was x plus 1. What's the other side have to be?
2x plus 6.
Excellent answer.
I'm going to bed now.
No, not for another 12 minutes.
It's been 1
See,
minute.
this is the other thing. Ask my sons. There were plenty of times when I spanked my sons. They were never, I wasn't mad at them. There were times when I had to stop laughing, but they still got spanked because discipline is a gift.
I don't think they're even here now.
Yeah, they are. They're on the other side with the camera, with their camera off. Because, yeah, they were starting to be distracting because you were cracking them up because you're being, how old are you? He doesn't even know how old he is. All right, let's build another one.
Okay. Bye.
Wait, we're going to build another one. You are. You want more x squareds or less x squareds?
More.
Okay. Oh, how many more? You want to do 3 or 4? Let's do 3. Let's do 3.
I'll set it up. I'll set it up.
I'll tell you what. You build one, and then you tell me. Why did you have to get rid of the other ones? You had to get new.
Yep.
Okay. Fine. All right.
Old ones.
Oh, you're gonna build a big one? Cool. Bring it down towards you, so that you have space. You know what I mean? You got. Yeah. There you go. Boink.
Can I go down to my BB shooting with the BB shooting gun down in the basement, then come back up?
No.
Can I?
No. Anyway, build this. What are you building? You're building a huge one. What are you making? So far we're gonna have 9 x squareds. I can already see that. Then what? Yeah, throw some of those in just for fun. And for those of you watching at home, you can't do this with girls. You can't. You will get nowhere with girls. All right, try it. Stick some in there, and then you got to make space in the corner.
People are watching at home?
Yes, there are. Many people will see this.
Live or?
No, and recorded.
Yep. Spread big jumbo.
Yeah, get them in there. And by the way, for future reference, you should never spank your kids if you're angry.
I wrestle my dad when he gets mad at me.
There you go. You wrestle with him. That's awesome.
Yeah. I usually like.
I used to have to wrestle with 2 boys, and usually I could take one of them, but the 2 of them together, oftentimes they could. We were out in the. Remember that at the they're. I don't know if they're there or not, but anyway, we used to have this big park across from the house that we lived at, and we used to wrestle and run around in there. All right, now put some on the other side.
Yeah, I usually push him against the floor when he's trying to push back. I can beat him up, but
Yeah, not yet.
yes, I can. I actually can.
He's gonna see this. Maybe he'll test you.
Can we stop the recording?
Yeah, there you go.
I'm just kidding. Keep going the recording. I'm fine with that.
All right. Now, what are you gonna put in the corner?
No idea.
Well, that's what I'm saying. What do you got? What are the 2 factors? What are the 2 sides of the corner? I see you're grabbing 5s.
That's
So
20,
what? Oh, so it's 5 by 5. Did you
35 to 34. 35 and 34.
wait? What?
35.
Oh, if you're doing base 10, do base X. It's actually easier. You'll see. So actually, what you have there is okay. We'll do that first. You counted the across 3x plus 5, right?
Yeah.
And then what's the other way? 3x plus 4.
Yeah.
Okay, now tell me the whole thing. You got to count everything. Count the big red ones. How many big red ones?
9.
9. And what are they called?
X squares.
There you go. Got to know the name of it, right? 9x squared. Then how many x? Got lots of x to count. The blue ones.
3, 4, 7, 4, 8, 12.
Excellent. So wait, we'll keep track. 12 on the one side. How much on the other?
15.
15. What's 12 plus 15? That's a lot.
27.
27x. Plus, how many in the corner?
20.
I know, right? Because one side's 5, one side's 4. It's got to be 20. Boom. That's crazy. That thing's huge.
Crouton.
See, now here's the thing.
Oh, okay.
Jack. If I would have given you this, you would have had to build that.
Mhm.
Right? Now here's the other thing. Let's get even more crazy. What if I said one side was 3x plus 5? We made it a division problem. What's the other side have to be?
15.
Well, try again. We're in x. Well, I know the one side's 3x plus 5. The whole thing is 9x squared, 27x, and 20. What's the other side got to be? That side. Because I already told you this side, right?
Yeah.
So you just have to tell me the other side, which is 3x plus 4.
Wait,
And
this
then let's do the math. Look over here. And actually, you know what? You had your paper and pencil out? Get your paper and pencil out and copy after me.
Uh-oh.
You got pencil?
It's under here.
Okay. You could draw a picture, right? To go with it. Here. Now, here's the only thing, Jack.
Yeah.
You got to pick the ones on top and put them on the bottom. Because when we do division, the pattern changes.
Okay.
So the guys got to go, you got these guys over here like this, right?
Which guy?
The X's. Then you got to put them down here instead. So right now you have on top. You just got to put them on the bottom.
Right here, Henry.
How many is that? 1, 2, 3. Okay, it's good enough. That's a 20 right there. This
What?
is supposed to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, there you go. There's my quick sketch. Now watch. 3x times 3x. 9x squared. That's this, right? 3x times 3x. Then what? 3x times 5 gives me, that's these guys right here.
Hey,
Three
Krupa, sorry to
times-
interrupt. We can't see the right side of your screen because the image is now, yeah, thank you. It's kind of small because it's split in 3s.
Oh, yeah, that's right.
All right, we see
Okay.
it now.
There you go. And then see, there's my drawing.
Yeah.
Okay.
Drawing is hiding a little, but
Can you see the whole thing now?
move a little to the right to see the right. Yep, stop. Okay. You got it, Jack?
I like it. Everybody's in there now. Jack just built this huge thing. And then here's all I was saying, Jack, is pick the ones on top and put them on the bottom.
Take the ones on top and put them
All
on.
the X on top and put them on the bottom. In other words, you're gonna have the same, yeah, exactly. It's just that they're gonna wind up in the bottom. And then you're gonna have to put the 20 down there too, right? Obviously. There you go. So what we're doing is we're gonna count 3x plus 5, 3x times. And I'm gonna try and get my boys to turn their camera on, and I was gonna introduce you to my sons.
We'll move our faces.
Okay, so Jack, what we did so far is we went across the 3x, and we went across the 3x. That was actually 9x squared, because 3x times 3x is 9x squared.
Can I
Now,
also-
when I go 3x times the 5, these 5 groups of 3, I get 15x. What I count? I counted these. 1 group of 5, 2 groups of 5, 3 groups of 5 right there. 15x. And then what? I didn't count these guys because I just stopped right there.
Yep.
All right. So then, well, that's nothing. I know this is going to be what? 12x, right? That's all these guys down here.
I think if your sons were here, they'd listen to you. So you're probably not.
Well, we'll see. Hey, Julia Marcus and Ben Isaiah, turn your camera on.
Yep, they're not. Oh,
There you
Oh.
go. That's
Hi.
Julian Marcus. This is Arena.
Hi,
She's
guys.
How's it going?
she's from Ukraine. Well, are you
Oh,
from
good to meet you.
Ukraine or just or
Yeah, from Crimea, but I moved here 20 some years ago.
okay? But I mean,
Oh,
but
wow.
you actually are from there. It's like me. I'm Lithuanian, and so is he. But we've
you-
never been to Lithuania.
Oh, well, you have to visit. It's gorgeous there. But no,
That's
yeah,
what I've heard. I've heard Lithuania is a beautiful country, but I've never been.
yes.
But I have many relatives because my grandfather was from Lithuania, and he was like you. He had moved from Lithuania to the United States, him and his brother. And then we had the Great Depression, and a bunch of stuff happened. And my grandfather stayed, and my I guess that would be my granduncle said, "Screw this," and he went back to Lithuania. So I have a whole family of first cousins, once removed, and so on in Lithuania that I've never met.
Absolutely go. Make it a point.
I hear this.
Whole family. Good
Yeah.
food, very cheap.
I know, and they'd be just fascinated to meet us because we are directly descended from a guy named Ben Gramatis, right? And that's actually, I guess, a pretty big family there in Vilnius.
Huh.
Anyway, little boy. Oh, wait, and then where's your brother? Is Ben Isaiah there? Oh, okay. And there's my other boy. That's the older one. He just returned from traveling. He spent like, 10 months in Southeast Asia,
Awesome.
enjoying him.
Multiple
back-
monasteries.
back math.
You guys say hi?
Yep. Oh, he met him earlier. They were here earlier.
Can you
Okay. They were he was doing his best to make them laugh, and he did a good job. All right, wait, we've only gone till here, right? We went across the 3x part. We went across this part. When I multiplied this times that, that's this part right here, 3x,
Yep.
right? 3x times, okay. So now I'm going down. Now I count what's left, and it was 12x and 20. And now what do I have to do? I have to cross those 1, 2, 3, right?
Mhm.
How many's there? Count it on yours. You've got it built right in front of you. Count it.
How much is annual?
I'm saying, how much is it from here to here?
900.
Well, I'm just counting the edge. We've been through this.
Oh, the edge.
Just the edge right there. Yes.
Oh, that's 20, and then the rest is 27.
Well, I'm talking about, okay. We'll try it again. If I have, you're trying to make this hard. If I have some 5s, and I do have some 5s, look at these. And see, and we'll bring home the point some more. See, this is good for everyone involved. See that right there?
Mhm, yeah.
How much?
20, I think.
20. What's this side?
5,
You're trying to tell me it was 20. What's this side?
4.
And you were trying to tell me it was 20. It's only 4. It's only 5. All right. So if I tell you that the whole thing is 20, right, and this side's 5, what's the other side have to be? Yeah, we're just looking at the very bottom corner. Right? We're just looking at that very bottom corner.
So it's answer.
Right?
Oh, so
So far as we've gone down the 3x, and now I look down and I still have 4 to go. But it's not just 4 because you got the whole thing there. So it's 4 times the 3x, which is 12x, and 4 times the 5, which is 20. And now we have nothing left to count. We counted this block. So all we did was count it in 2 blocks. That's this one. That's this one.
Mhm.
Now it's the same thing. If this was base 10 mathematics, it would be 35. This would be 34. Ooh, you tell me how much that is. Take it for homework. But actually, you have it right in front of you, right? You can count. These are hundreds. These are tens. And there's 20. So don't forget that that's 2 tens, right? And this is if I arbitrarily tell you that x is the same thing as 10. Right?
Mhm.
Because x could be 5. X could be square root 2. If x is 0, well, then all of this is gone. Just to say that. And all of that's gone. And what do we have? Just that. Right? Because none of the rest of that exists. If x is 0, then it becomes a super easy problem. The thing is just 5. The whole rectangle is 20. And the other side's 4.
Yeah.
That's just looking at this thing right down here in the corner right here, right? But then when we built the whole thing, we had more to do. And I'll remind you that you're the one that built this problem. But the point is, it teaches you how to do division. Makes it easy. And in fact, I think my boys can attest to the fact that algebra is actually easier than base 10. That's why and there you go. See, and that's why when we started out, when they were 4, 5, and 6, I started them out with algebra because algebra is generic mathematics. Then we can add base 10. Okay. And Irina, I'm going to say, you're getting $1 a minute is my charge, right? Technically not, because I gave you a couple free classes, but still, if it was like, it'd still be $1 a minute, right? Okay. So I want to make sure that mom gets full value. Your son, on the other hand, could care less about any of these. So what you need to do is either put a adult, like your husband or you, in the room for a little while we do math until such time as he can behave himself and do math without an adult there.
Got it. So let's
because it's your money.
Yeah. Because I'll be home by 5 p.m. Eastern. So yeah, let's take. I thought maybe we can do it separately, but no, I agree.
Yeah. And then when you can behave, JAQ, you can have math on your own time. But since you can't behave, and see, like I said, what do you call? It's not a big deal, right? He's a boy, and you want that out of a boy. You know what I mean? I mean, I've had both kinds, the total docile ones and so forth, right? And then there are ones where it's like, oh, he's like that, we should give him drugs. No, don't give him drugs. Right? You want boys like this. You want the ornery ones. You want the ones that have personality and the kind. But I want to teach you math, JAQ, and you can't do it when you're screwing around. Okay. Let's build another one.
Quickly. Take this pillow out. I'm not sleeping.
Yeah, we're technically out of time, but I don't have a class.
Oh yeah, sorry.
No, that's fine. I don't have a class for who's left. I have McCrae is left. Let's see here. And he'll come in, and if it was him next anyway, he'd come into this chat, so it'd be fine. Then we'd have 4 of you, but we don't need to. All right, so how about you want a hard one or an easy one?
Easy.
Sure, I see how it is. All right. Here. Oh, all right, we'll do this. How about 4x squared? That's a square. 4x and 1. Tell me the factors. In fact, I'll give you a huge thing. Give me the square root. That should be a big clue. And you should be able to see it in your head. I like it.
400.
Hold on a second. We're in base x. So it's 4x squared, 4x and 1. What's
21.
one side?
21. 21 on this side, 21 on that side.
That would be correct if this was 441, but it's 4x squared, 4x and 1. So what are those blue ones called?
2x plus 1. 2x
Yep.
plus 1.
Now here's the thing, JAQ.
Yeah.
Are we going to write this like this? 2x plus 1. Am I going to write it twice? Hell no, I'm not going to write it twice. I'm going to do that, right? Economy of symbol. That means this, but see, mathematicians, just like you, JAQ, we're lazy.
Same by same is a square.
Right? So I'm not going to write it twice. I'm just going to write it once. Now, this does mean the exact same thing, right? 2x plus 1, 2x plus 1. But why would I do all that when I can just do this?
Do you see that?
And that's the same thing as this. Okay, so these are 3 separate things that mean the same thing.
Yep.
Got it?
Mm-hmm.
All right. And you did fine. You didn't have a problem with that at all. So let's make it a little more tough.
No.
You can handle it.
No, I can't.
Yes, you totally can.
I can only handle eating lollipops or sweets.
I know. There you go. That's the other thing. Before class, probably beef jerky and water or something like that.
Yeah, beef chili.
Yeah. Okay. There you go. But I mean, for snacks, you don't really snack on chili.
He just eats chili as a snack.
I'm about to eat Portuguese soup as a snack. How about 3x squared plus See, and I'm just looking in my mind. I have a picture in my mind. 2, we'll go 3, 6,
Oh, yeah,
9, 11, and 6. Oh, well, we won't do 11. Let's do
I just said that.
4, 2, 4. Let's do 9x.
Look at that. Build.
Oh, 9.
No, not enough. Not enough. Oh wait, you know what? It's fine. Well, it's fine. We'll do 10x. How's that? And then we'll have plus. I'm drawing it now because I'm. See, now you have to see if your drawing will match mine. There you go. 10x plus 3. There you go. Make it super easy.
Like this?
What do you think? You got to fit 3 in the corner. Now, here's the thing. You like 3. You know why you like 3? Because 3 goes like this, or it goes like that. That's the only, right? You can't turn 3 into anything else. So you got to put 3 in the corner. How are you going to do it? I like it. See? Because when you put it like this, it didn't work. You got to put it like this, huh?
We were talking about how we would do it. And
Yeah.
Jack, we both very much like your method of choice.
Yeah, we do.
That was as good as what we came up with. So good stuff.
Yeah, that's right. Just count. Do you have 10?
1, 2, 3. 3, 6, 9.
There you go. Look, he had to use skip counting. All right. So what are my factors, young man? I think you got it.
No idea.
Yes, you do. Count the sides.
I still have 1 extra.
You don't. You need 10. You don't need 11.
3x plus 1, 3.
I like it.
1x plus 3.
Wait a minute. 3x plus 1 and an x, right? Do I need to put 1x like that? Do I need to write 1x?
Nope.
I can just put x, right? Okay, that's another thing that confuses children often. Okay, so I have 1x plus 3.
Yeah.
All right. That is the correct answer. Good job. Good job. Yay! Okay. And I could turn it into a division problem. Oh, how about I do this? Let's get crazy. I'm going to give you the sides, and you have to build the whole thing.
Like,
Yes, you can do it. You can do it. How about 3? How about a pen that writes? Let's get another.
Give you a pen that writes.
I have a few pens because I ordered a big box of pens. So it's just a matter of grabbing one that actually writes.
Oh my god.
Yeah. Okay, how about? See you? Ooh, oh, but that's brown. I don't want brown.
You said a pen that works. Not.
Yeah. That's important. 3x. When you're teaching math, you gotta have pens that write. 3x plus 2, just for fun, and we'll make the other way 2x plus. We don't get too big. How about 5?
start with the x's. Start with the 10.
So now I want it to be 3, 1, 2, 3, and 2 going across. Oops, 3. And then I need to be, let's see, 4, and then I got 2. I don't know. You build it. So immediately, how many x squareds are you going to need? Right off the bat, Jack.
Uh,
How many x squareds would you need?
5.
Try again.
7. 6.
6. So grab 6. Little boy, pay attention over here. I like the little brother is here. They learn by osmosis, by the way. They just sit in the room, and then you'll be amazed that when you try to teach him math later, he'll quote unquote just know it. But no, it's because they actually absorb it. All right, so then yeah, you still got to fill in all your x's, and you need more x squareds. Get the rest of your x squareds in there.
Oh, I do.
Come on, Jack. Move it.
Yeah, focus. All right, now look, you're 3x squared. Now you got to be 2 on the edge. Get 2 on the edge. Right now you have 1. You need 2. 2x. I'm sorry. See what happens when you're not specific with your language? You need 2x because it says 3x plus 2. Right now you're 3x plus 1.
Like this?
Oh,
There you go. Then what's it got to be? Oh, now you can't go more than 2. Now what do you got to go up? 2x, and then you need 5.
How do I-
Bam. Bam. Throw them in there. You need 5. You need 5x up there. So far, you're 3x plus, I think it looks like 3x plus 2.
Yes.
You want to be 3x plus 5. So you got to keep going. And this is why, again, multi-10 so happy, because it makes it go so much faster.
Nice blessing.
All right, and then what's going to fit in the corner? 2 5s.
But is that the right equation?
All right, now count the whole thing and tell me what it is.
3,
Right. Start with the big red ones.
9.
Wait a minute. How many big red ones?
Count.
6.
6 big red ones.
6 or 7.
You tell me, little boy, go over there and count the big red ones. Let the little boy count the big red ones. Count them.
You just,
6.
you just
Okay.
like to say 6, 7.
All right.
Every kid
6
says nowadays.
of them. All right. Now, how many of the blue ones?
Come on, count.
These guys. The blue ones are called X. So how many of those guys?
The same is the same as the same, and then the other two.
Yeah. How many of these
Me?
total?
Me?
Yes, you.
23. I thought.
20, 23. Are you sure?
Can you recount, please? These are the
Yeah,
same.
5, 10, 15.
190.
Okay.
Wait, how many?
15.
Here, but what about this?
19,
Yeah, there you go. Got to count them all.
22,
190.
15 plus 16, 17, 18, 19. Jack, wake up.
Seriously, wait, relax, Mom. But here's the deal. I know it'll make you crazy, but you got to have patience. And he enjoys seeing if he can piss you off. Trust me on that one. All right. So 5, 10, 15. Again, these are some of the ones you want. You want some of the ones that have no issue. All right. So 5, 10, 15, and 4 more would be 19. Apparently, Jack was having trouble with 15 and 4 more.
I was.
Apparently, you didn't count it right. All right. And then what's 2 times 5?
10.
There you go. All right. So there you go. If I multiply this times that, I get this. That's all it is. All right. We're just doing algebra. And we don't even know what the numbers are. If it's 10, then this is 700 and... Wait a minute. How much is this? That's a 10. That's 19. So that's 200. That's 800. That's a really complicated way of writing 800 if X is the same thing as 10. And then I could have 800 divided by 25 is 32. 32 times 25 is 800. And see, my one boy, not this one, the other one, can tell you that a lot of times when he was doing math, it was easier to do the math in his head like this.
2 times 5.
Right. So if I want to multiply 32 times 25, it's easier to see, oh, the 6x squared is 19, and then add them up in your head. And you can do it really fast. Right. Makes you look like a genius, Jack. Now, here's my next question. Would you prefer to have them look at you as a genius or as a dork?
A dork.
I'm kind of right there with you, actually, when it comes down to it. But the idea is, if you can do mathematics, people think you're smart, right? And I know a lot of guys that can do math and they're not smart, but they can do math. But if you can do math, people think you're smart. I never mention at a party that I can do math, right? And oh, what do you do? I tutor kids in math. Oh, you're a mathematician? No. All right, Jack, do me a favor, because I saw this in the beginning of class. For your mom and for my boys, count for me by 7s without looking in your tray. Just count 7s. Just say it out loud.
You can do it, bud. You can do it.
Yes, you can do it. Just sit back.
Oh,
And
we
close
did.
your eyes.
Okay.
All right, wait, Jack, I'll show you a trick. I showed this to the other guys too. I'll show you this. Watch. 7, right? Here's 7. Now, what does 7 want to be? It wants to be 10. So I'm going to cover the 3 and I get 14 because that's a 10 and 4. Grab a 7. And then what? 14 wants 6, so now I have 21. And then what? One's not happy because he only gets 7. And right? Okay, so count for me by 7s, Jack.
7, 14,
No.
7, 14, 21, 28,
Wait. Oops. 21. Then 28. There you go. Don't want to skip it. Then what?
35,
Got it.
42,
Excellent.
49.
What's cool about 49?
It's 49.
Well, just being 49 is cool, but what else is cool about 49?
It's 49. I don't know.
You don't know?
I don't know.
Yes, you do. But
No, I-
here. Wait. This is why my students recognize square numbers. What shape is that?
A square.
7 sevens is square. That's what's special about 49. 49 is also cool just because he's 4 and a 9, but 49 is also square. Okay. What's the next one? Which should be easy. 8 of them.
56.
Got it. Keep going. 9 times 7.
3, 63,
Excellent.
70.
70. Okay, stop. Fine job. Little slow, needs to be faster, but fine job. All right, now 70 plus 7, that would be 11 of them. 77. 70 plus 14, 84. 91, right? 98. 105. Go watch Lucky Seven Samson.
Right.
112, 119, 126, 5 and 7. 5 and 7 is 12. And there's just a 6 along for the ride. Then it's 13 and 3. And then what? 140. Done. Oh, you got a little boy in the room. Little boy. Can you add? Can you add?
Your head. Can
Can you add? What's 1 plus 4?
I forgot.
What's 1 plus 4?
I forgot.
What's
Come
1 plus 4?
Stop playing.
I forgot.
Henry, get
That's
out
not a
of
good
here.
answer. What's 1 plus 4?
6, 7.
Henry, you're being mean right now. Don't talk to him.
67.
He's-
5.
Stop.
5.
It is 5.
That's disrespectful.
See, in Hawaii, we say sometimes they need cracks. Okay.
I'm afraid to know.
Cracks in the. Oh.
7. Oh, wait. Let's go black. Let's go red. So let's see here. We have 7. What's 1 plus 4? 5.
Henry, what's
Jack, what's 2 plus 1?
That's
3.
What's 2 plus 8?
Look, N.
2 plus 8. 10. I'm doing
everybody-
something.
Okay, and then 1 plus 0 is 1.
Oh,
What's
not
3
here.
plus 5? What's 3 plus 5?
Henry, 3 plus 5.
Let me think about it.
Stop.
We don't have this much time. What's
Yeah.
3 plus 5?
Jack.
I like it. What's 4 plus 2?
4 plus 2?
Come on.
Okay, I'll think about it. 4, 5, 6.
6. And then you also have to remember, he's running at a slower processing speed.
I'm 6.
So he does actually have to think about it to get an answer, right? We get it fast, but he's running at theta. He's not running in beta. So it takes him longer. All right. What's 4 plus 9? Ooh, that's for Jack. Jack, what's 4 plus 9?
6.
Don't repeat.
13.
There you go.
Just think.
And then 1 plus 3 is 4. Julian Marcus, this is where you get casting out the 9s. Because why even bother? Right? It's just going to wind up being 4 anyway. All right. What's 5 plus 6?
Is that for me or him?
Yeah, you.
You. What's 5 plus 6?
11.
And then 1 and 1 is 2. Very good. What's 6 plus 3?
6 plus 3 equals
7, 5, 3, 1,
6 plus 3.
9.
I already said that.
9. You
It
said
is
that.
9. Okay. I didn't hear it. Okay. Now look over here. 7 and 7. Okay. Oh wait, and then this 7 plus 0 is 7. All right. So look, we seem to have a pattern: 7, 5, 3, 1, 8, 6, 4, 2, 9, 1. Okay. Now we look at 7 and 7, which is 14, which is 5. Oh, look at that. And then I can just already tell you it's going to be 3, 1, cast out the 9, cast out, right? And then we wind up with 8, and then we wind up with 6. Oh, look, there it is. And then we wind up with 2 and 2 is 4. And then look, cast out the 9, and you get 2 again, because 1 and 1 is 2. That looks like a 9 to me. And then, oh, look at 7, because 19 times the number is always the number. And then 5.
I can't see these. I haven't.
So why is 4, 9 is always cast out? I feel bad for
Yeah,
it.
he's cast out because it's might as well be 0.
Necessary.
There's a whole long thing where 9 and 0 are really good friends, and they're almost the same. All right, let's do some more. What if I had? I'm only going to do 3 of them. 1, 4, 7. Let's see here, and then what? 1, 5, 4. And then I add another one, and I'm going to get 1, 6, 1. According to my calculations, without even adding anything up, it seems to me that this should be, well, let's see here, 5, 3. Oh, look, 7, 5. Oh, look, 7, 5, 3 comes next, right? 7, 5, 3. 7, 5, 3. That means the next one should be 1. That means the next one should be 8. I don't have to add them, but I do know that 1 plus 6 plus 1 is 8. Oh, does it keep going? Is the pattern the same?
1, 3, 1. So you wouldn't reconstruct it from the pattern, though, right? From the reds, you wouldn't go back to the numbers. It's just
it depends. You have to know what. Yes, you're correct, because it's hard to go back that way if you don't know, right? Because 8 could be a lot of things,
right.
right?
Yeah.
Because I mean, 8 could be
98 or 35.
yeah,
or
exactly. It could be a lot of things, right? Okay, I've had students that go out like to 900 to see if the pattern ever breaks, and it never breaks.
That's awesome.
All right, Jack, you have homework. Your homework is to practice your multiplication tables so that when I ask you what 7 times 7 is, you don't go, I don't know. You just say 49. You don't repeat the question.
I forgot.
Yeah, you don't say, I forgot, like Henry, right? You just say 49 because you know.
Okay.
Okie dokie.
And you know what? He never did that.
Okey-dokey.
He never did the grain of sand or
I
rice.
know. I already knew that. All right. So do the green, do the rice on the chessboard.
Yeah.
What?
And that's just going to be doubling, right? Or adding.
Right.
Wait, Jack. I'll do some for you right now. Watch. 1, and then 2, and then 4, and then 8, and then 16, and then 32. Look, I can do it easy in my head. 64, 128, 2, 5, 6, 5, 12. I can do this all day. 10, 24, 2, right?
You got it?
Right, that's you. I've gone how many pieces on the chessboard? 1, 2, 3, 4, 5, 6, 7, 8. So we've made it through the first row and half of the second, and we're already at 2048. What happens when we get to 64? And I think you're going to find out. We get to 1 billion right around 30.
We're going to 1 billion?
Oh, you're going past the billion, young man. Okay. You have 2 pieces of homework. Do that checkerboard from last time and practice your multiplication.
Okay.
And next week, when are we doing class? Because we're not doing class by himself.
Yeah, we're doing class together, so let's do 5 p.m. because that's job. Sorry. Because I'll need to be here. So it's the 8th, right?
So see, your behavior, son, is inconveniencing your mother. It doesn't bother me. I find it amusing.
What's the music?
But it wastes your mother's money, and now it's wasting her time. Because she shouldn't have to be there. All you have to do is behave and pay attention and do some math. We're just playing with blocks, and I'll give you a serious warning. If you can't learn math this way, you're not going to learn math. Because they're just going to give you symbols and pieces of paper. So pay attention in the next class, and then if you behave for a couple classes, then your mom can leave. And you got like what? You got like you're paid for like another 5 or something like that. So we got plenty of time.
Got
See, that's why we call it Mortensen more than math, because there's a whole lot more going on than just mathematics. And by the way, do you think this is the first squirrely kid I've dealt with in 35 years? Anyway, all right. So what time next week is what I'm saying? Monday at
5 p.m. our time, 3 p.m. Arizona.
that'll work.
Okay, awesome.
That'll totally work. Except for one thing, send me an email ahead of time so I'm not spacing out
Uh,
and he's not sitting there waiting for me.
I'll remind you on Sunday.
Right.
For Monday.
And here I'll stop the recording and I'll give you my girlfriend's number so you can
I have it.
necessary. Oh, you already have it, right? The 323?
Is it Trish?
Yeah.
Yeah.
Okay, good.
Yeah, we exchanged.
All right, excellent. Okay, I will see you next week. And again, no worries. It's a boy. They're 2 boys, and that's how boys are.
That's good.
And then you got a sister on top of it. So look, it's the same thing as you guys. 2 boys and a younger sister. Oh, wait a minute. Who's the youngest one? The girl or the boy?
Me.
No, Kira is 4, so she's the youngest.
Okay, so Kira's the youngest. So same thing, yeah. 2
Yeah.
older brothers.
That's awesome.
So this is the cool thing. The 2 older brothers should teach the younger sister some math. And because you were screwing around so much, we didn't get a chance to play What's Under the Cup. I know. See how it is? All
Yep.
right.
Next time.
I will what do you call? See you guys in a week, and we'll kill the recording here.
Nice to meet you, guys.
All right, and you'll have to actually hang up.
Okay, I'm hanging up.
Bye,
Thanks,
guys.
Bye.
Hey, good to meet you guys. Have a
Meet
good
you
one.
guys.
Oh, there she went.
There you go, and then we end the recording.